We'll now begin section 1.6 and discuss linear inequalities in one variable. We'll begin with a few examples of how to solve linear inequalities. Our example says, solve the following inequalities using interval notation to describe the solution set. You will find that as we work these inequalities, that in most cases, the inequalities are solved exactly as we would solve an equation. In other words, if this problem had had an equal to sign, it would be solved in much the same way as we are solving it as a less than or equal to, with one or two exceptions. So let's begin with part A of the problem. Part A says 5 minus 2 times the quantity x minus 3 is less than or equal to negative and then the quantity 1 minus x. So we can begin pretending for a few minutes that we have an equal to sign and not a less than or equal to. And so we treat it the same way. Our goal is to simplify, getting the x's on one side of the problem and everything that does not have an x on the other side of the problem. So let's begin by using our distributive property on this negative 2. And also the distributive property on this negative that sits in front of our parenthesis on the right-hand side. So I'm going to have 5 minus 2 times x would be 2x, and then a negative 2 times a negative 3 would be a positive 6. And we'll have less than or equal to, and as we distribute our negative, we'll have negative 1. And then this negative and this subtraction become a positive x. We'll combine what we can combine. For example, we have a 5 and a 6, which will combine to make 11 on the left-hand side. So we have 11 minus 2x is less than or equal to negative 1 plus x. Then if our goal is to get the x's on one side and everything that doesn't have an x on the other, we might begin by subtracting x from both sides of the inequality. So that would give me 11 minus 3x is less than or equal to negative 1. And then our next step would be to move the 11 over to the right-hand side. So we would subtract 11 from both sides, giving me negative 3x is less than or equal to negative 12. And then finally, we would divide both sides by negative 3. Now remember when we started, we said that in most cases, solving an inequality was the same as solving an equation. So we have not done anything different on this problem yet than we would have done if it had started with an equal to right in between instead of a less than or equal to. And we said with a few exceptions, the main exception that we see is that if we divide or we multiply by a negative, you need to change the direction of the inequality. So if it is a less than, it will become a greater than. If it is a greater than, it will become a less than. And this is the main way that an inequality is different from an equation. So as I divide by this negative 3, I get an x. This less than or equal to becomes a greater than or equal to, and then negative 12 divided by negative 3 would be 4. And so our final answer would be x is greater than or equal to 4. And in interval notation, this would be all of the numbers starting at 4 and going to infinity, because we said that we were looking at the x's that are greater than 4, so 4 to infinity. Remember that we're always going to have a parenthesis on the infinity, and because this is greater than or equal to, because of the equal to, we'll put a bracket on the 4, and that is our interval notation. Okay, so let's move on to part B of this problem. Part B gives us the fraction 3 times the quantity a minus 2 over 2 is less than 5a divided by 4. Now remember, if this had had an equal sign in between, our first step would be to try to eliminate the fractions by multiplying both sides by the least common denominator. So if our denominators are 2 and 4, and we look at some multiples, we would have 2, 4, 6, 8, and so forth, and 4, 8, 12, 16, and so forth. And the smallest thing that they have in common would be the 4. And so we're going to take this expression and we're going to multiply both sides by 4. So when we do that, we can reduce here. 2 goes into 2 once, 2 goes into 4 twice. And on the right-hand side, it's just going to cancel out altogether. So over here, we have 2 times 3, which is going to give me 6, times my quantity a minus 2, is less than 5a. We'll use our distributive property to distribute the 6 through the parenthesis. So 6a minus 12 is less than 5a. And then our goal becomes getting the a's on one side and the numbers on the other. So we will subtract the 5a from both sides, which gives me a minus 12 is less than 0. And then we'll add the 12 to both sides, which gives me a is less than 12. And that is our answer. A is less than 12. In interval notation, we're talking about numbers that are less than 12, so those numbers would begin with negative infinity and go all the way to 12. We always do a parenthesis on the infinities, and because there is no equal sign on our answer, we'll do a parenthesis on the 12. So any number from negative infinity to 12 would be a part of that solution set. Now, oftentimes when we work problems, we're going to be asked to give our answer in this format and also in interval notation and also to graph the solution set. And so let's look very quickly at a few examples where we are graphing our interval notation, and let's just remember how that's going to look. So we have 3 intervals here. We have the interval from negative 3 to 6. The interval from negative infinity to 5, and the interval from 2 to 9. And we just are asked to graph those intervals, and you can see that that's done on your screen for you. From negative 3 to 6, notice that we put a bracket on the negative 3 because there's a bracket on the interval notation. And because there's a bracket next to the 6, we're going to use a bracket next to the 6 on the graph, and we're going to shade in between. For part B, we have an open interval from negative infinity but then closed on the 5. And so we'll put our bracket on the 5, we'll shade all the way to the left, and in coloring in that arrow, that indicates that it continues on until we reach negative infinity. Technically, you can't reach negative infinity, but it continues on forever in that left-hand direction. And then for part C, we have an interval closed on the 2 and open on the 9, so we'll put a bracket on the 2 on our graph, open parenthesis on the 9, and shade in between. So just you would want to familiarize yourself with how to graph your solution set.